This video is for trig section 9.2. So again, we just have a little bit of algebra review because in these sections that we're covering right now, there's not really any new trig knowledge. We've done all the trig of this before. We're just mixing in a little bit of that algebra, which I know can be intimidating. So thinking of this easier problem right here, if you remember, if you had me for college algebra, I said this one looks like a headache, so we took some Tylenol. So we said that the least common multiple, the least common denominator would be our Tylenol, which would make the headache go away. So I want something that would make all of the denominators cancel. So right here, this first guy, he's a whole number, so really he would just be over 1. The second one, of course, has a y in the denominator, and this has a y squared. So if I wanted to make things cancel by multiplying everybody by the same thing, it might seem like a y would do it. If I gave everyone a y, that would take care of this 1, that's fine. It would take care of this y, but a y wouldn't completely cancel the y squared. So it would reduce it, but I need it to completely cancel. So I always want something that would make it not just reduce, but completely cancel. So what I recommend, the first step in any of these problems is to rewrite it. So I rewrite the problem with some space in each fraction right here. So I put a little space right here, minus the 3 over y, with some space right here, equals the negative 2 over y squared, and a space right here. And in those spaces, I put the thing that would make the headache go away. So we decided it wouldn't just be y, because y would cancel him, but not him. So I need not just y, but y squared, because y squared would make him cancel, y squared would make him cancel, and really there wasn't anything to cancel here, so he'd be good. Now if you needed to kind of line up, all of these would be over 1. Not really necessary, but if it helps you kind of line things up in your mind, then good. So I'm going to multiply each of these by the same thing. Now we know this is mathematically allowed because really what I'm doing is I'm multiplying both sides by the same number, which is the multiplication principle of equality. And right here on the left, I'm doing that and then just distributing it to both of these terms. So that's why this is mathematically allowed. I'm not just changing things, I'm just multiplying everybody by the same thing. So this gives me 1 times y squared would just be y squared. This one right here, like we said, it reduces. So this was y squared, which is y times y. So one of those two would cancel this guy, which would leave me minus 3. This y right here that didn't cancel equals, over here, these y squareds would completely cancel and just be a negative 2. Now at this step, at the very second step right here, you should have no more denominators, no more headache. If you still have a denominator, probably what you did is right here, you just multiplied by a y. You didn't go big enough. So you have to make sure that you get a big enough thing to cancel all of the denominators. So go back to this step and see if you need to put anything else in there to make it all cancel out and go away. So at this step right here, you should have no more headache, no more denominators. And then it's just regular solve. So I see I do have a square, so that means I can use my quad program as long as I get it equal to 0. So then I move this 2 over. Careful not to combine unlike terms. That would give me y squared minus 3y plus 2, because he wasn't a like term, so he's just over there with them, equals 0. I use my quad where this is my, understood 1 is my A, B, and C. And that's going to give me that y is equal to 2 and a 1. Now remember, on these problems, I always had to be a little bit extra careful of my answers because we know that there's that mathematical rule that we cannot divide by 0. So I'd always have to kind of double check, go just back with my eyeballs in my brain and just make sure that these two answers would not make me accidentally divide by 0. So in this case, it's pretty obvious I would be dividing by 2, which is not 0, and 1, which is not 0. But remember, sometimes we'd have more complicated denominators, so I'd have to just double check really quick. So these are both okay. These are my two answers. Okay, but I point that out because we may have a trickier one here in the trig. So we're going to use the same exact idea with our trig stuff. Remember, there's nothing new. We're just kind of applying this algebraic concept. So we already learned that cosecant is 1 over sine. Remember, they're a little backwards from what you would think. So square root of 2 cosecant would really be square root of 2 over sine, because cosecant is 1 over sine. Okay, so just remember this is 1 over sine. The sine's on the bottom, but that did not move the square root of 2. Square root of 2 was just next to him, so he's still on the top. Plus 4, okay, that's whole number 4, so he'd just be like over 1 equals 2. Now, just like our original here, I want to get these denominators out of the way. So really the only thing in the denominator is a sign. So I'm going to multiply everybody by a sign. Okay, so I'm going to go and give everyone a sign, beta. I'm going to write it out at least this first time just to make sure it's super clear what we're doing. Okay, but after this, you can kind of just do this next part mentally. So plus, and then I leave that gap there to put a sign next to each one of these terms. The next one was just 4 over 1 equals, and then I put a sign right here next to the constant 2. Okay, we did this because it would cancel the sign on the bottom of this first term right here, which would give me just a square root of 2 plus 4 sine. We typically see the number in front of the sign so that it doesn't look like it's sine of 4 equals 2 sine. There we go. No more denominators, no more headache, at least less headache, right? All right, and now it's basically like a problem like we just did in section 9.1. So I want to get my signs together, treat sine just like a variable. Can't solve for sine if he's in more than one place. That's going to give me the square root of 2 equals negative 2 sine theta. Divide by that negative 2. That looks like somebody I see on my unit circle. Sine is equal to, hang on, let me squish that negative in front. Sine is equal to negative square root of 2 over 2 in 2 places on the unit circle. Okay, just for practice, we're going to find it in degrees and radians. So he is equal to negative square root of 2 over 2 in quadrants, 3 and 4. Okay, because sine is like y, so down there on the bottom is where he's negative. That would be the radian angle of 5 pi fourths and 7 pi fourths in quadrant 4. This is equivalent to check, the 225 degrees and 315 degrees. Okay, now in XYZ, it's only going to ask you for 1 degree, degrees or radians. It won't ask you for both like this. This is just for our practice so that you know how to kind of go back and forth depending on which question, what the question asked you for. Okay. All right, let's try this one. All right, so sine is just easy sine. Now remember that. That 2 is next to him. But just like our last one, cosecant is 1 over sine. Okay, so that means I need to multiply everybody by a sign. Okay, so I'm going to go through and give everybody a sign. I'll do it one more time just so it's super clear what's happening. So the 2 sign is going to get another sign. And then I'm putting that sign there in order to make this sign that was on the bottom cancel. Okay. And then over here, anything times 0 is still 0. Okay, so that would give me sine times 2 times another sign would make me have sine squared. Okay, these would cancel and just leave me a -1. Anything times 0 is 0. Okay, now right here you could do one of 2 things. You could solve this by hand, so, add the 1, divide by 2, and then square root. Now when you do that, make sure that when you square root both sides, you always do that plus or minus. You could also do your quad program in your calculator. So if you notice that it was a squared, we could do quad. we like that quad program, that'll work. Just make sure that you do enter an A of 2, and then something's missing here. So is it the B or the C that's missing? Remember that the C is the constant, so C is the -1. B is always next to the single, so right now it's the B that's missing. There's no just sign. It goes straight from sine squared to the constant. So we have 2, 0, and then -1. Now remember, it gives you the decimals first, and then if you hit enter one more time, it's going to give you that the exact form with square roots, but it does give you a 0. So just a heads up, it'll look like this. Erase this, that's why I'm writing sloppy. Okay, but we know that 0 plus square root of 2 is really just square root of 2. So right here, this is just an unsimplified version that we are going to simplify. So right here, when you hit enter that second time and get in an exact form, it shows you that the sign is equal to square root of 2 over 2, and sign is equal to negative, because 0 minus square root of 2 is really just minus square root of 2. Okay, so make sure that you take out that 0. Okay, you know that 0 plus something is really just that thing. And we see that this one right here, sign is positive in quadrants 1 and 2. And sign is negative in quadrants 3 and 4. Well, this guy looks familiar, right? That's what we just had right back here. So we actually already know these two answers. These were the 5 pi fourths and the 7 pi fourths, straight from our unit circle, which were equal to 315 degrees and 225 degrees. Sine is positive square root of 2 in quadrant 1 at 45 degrees, or pi fourths. And in quadrant 2 at 3 pi fourths, which is, out there, what is that? 135 degrees, sorry. Once you get used to radians, they're so much easier. All right, so we end up with these 4 separate answers. Okay. But wait. Now remember, back up here, we said we do need to be careful that we don't accidentally divide by 0. So in this one, it was obvious. If we plugged in a 0, it'd be 0. This one, what's in the denominator? These two problems, we have a sign. So anything that would make sign be equal to 0 has to be tossed out. Now sign is 0 at 0 and 180. So we're good. None of these are 0 or 180, so we're okay. But you need to watch out for those. Just be extra careful. All right. So this time I've got sine, cotangent, and cosecant. The first thing I want to know is what's in the denominator. So I'm going to rewrite it so that these are in their sine, cosine form, so I can see more clearly who's on top, who's on bottom, which trig functions are in the denominator. Okay, cotangent, remember, is cosine over sine. Okay, and remember that that 2 is on the top. It's not 2 cosine over 2 sine. 2 is the whole number 2 over 1. 2 is on the top only. And there's that cosecant again. Sorry, you'll definitely notice a theme in my examples here. I tried to give you a variety in how the answers work out. Okay, so if we had a secant, it'd be over cosine. All right, so again, I see that the thing I want to cancel is sine. So I'm going to go through and multiply everyone by a sine. And this time, I'm not going to write it out in green like I did here. We're just going to imagine. So I'm going to multiply each one of these 3 terms by sine. So this first one, sine times sine, would become sine squared. Okay, now this one, when I multiply him by sine, the signs would cancel just like they did here. So that would leave me with only 2 cosine. Okay, and this one I multiply by sine, the signs would cancel and leave me just the constant 2. So I multiplied everyone by sine, just like I did in these last 2 problems. Okay, now You might say, wait a minute, we've got a problem. I've got sines and cosines together. Now we learned how to do this in chapter 7. We said, okay, if we have this mixture, we need to get them together. There was a Pythagorean identity that we could use to switch back and forth. Now it always worked with squares, okay, and luckily we have a square. So we found that sine squared plus cosine squared was always equal to 1. So we could get back and forth by doing one minus the other one. So 1 minus cosine squared was equal to sine squared. And 1 minus sine squared is equal to cosine squared. So right here, I have a sine squared, so I'm going to switch him into this 1 minus cosine squared. Okay, so these are just some little pieces of information that I can use called the Pythagorean identities. So right here, I'm going to switch this from 4 sine into 4 1 minus cosine squared. Okay, so I'm swapping out my sine squared for 1 minus cosine squared. Okay, plus 2 cosine equals 2. Okay, let's color code it there. This changed to this. All right, so now I'm going to clean this up a little. I'm going to distribute that 4. That would give me 4 minus 4 cosine squared plus 2 cosine equals 2. You see that I've got all the same trig function now, so I can do it like a quad, like I did in these previous problems and like I did in section 1. So I'm just going to get it cleaned up and equal to 0. So that would give me negative 4 cosine squared plus 2 cosine. And then right here, if I subtracted this 2 over, 4 minus 2 is 2. Okay. And now I can use my quad. So my A would be negative 4, my B would be 2, my C would also be 2. Gives me the decimals first. And then if I hit enter one more time, it says that cosine would be the fraction of negative 1/2, or cosine would be equal to positive 1/2. Okay, so negative 1/2, that's going to be in quadrants 2 and 3, because cosine is like x, so it'd be over there on the left. And cosine is exactly one whole in one place only. So cosine, which is the x, would be exactly 1 all the way to the right at 0 degrees. 0 degrees and 0 radians. They're the same for that one number only. Okay, so this one right here, cosine is negative 1/2 in quadrant 2 at, let's see, 2 pi thirds. Let me scoot this over. Okay, hang on. I'm going to scoot this over so we can organize our thoughts. All right. So in quadrant 2, it is at 2 pi thirds. Okay, which is, let's see, 120 degrees. Okay, and then in quadrant 3, it would be at 4 pi thirds, which is 240 degrees. Double check. Yes, 240 degrees. Okay, and then we said it is exactly 1 at 0 radians and 0 degrees, but wait. Now remember right here, we said we got to be careful. We always got to be careful not to divide by 0. So what was in the denominator here? Sine of x. At 120, sine of x is good. It's not 0. At 240, sine of x is not 0. We're good to go. But what is sine of 0? Sine of 0 is 0, and we can't have 0 in the denominator, so he's out. So even though mathematically these values work out, if you tried to plug them back in, your calculator would explode and create that black hole. So these are your only two answers. So mathematically this one worked out, but the actual, not breaking the rules of the universe answers are these two right here. All right. Okay. So keeping our chapter 7 notes handy, because we can throw in a few more formulas here, and also keeping our section 1 notes handy that we just did in the last section, we're going to kind of combine these ideas. So this first one, just like we finished up on this problem right here, we said we had to switch that sine squared so that I could keep all of the same trig function. We're going to do that exact same idea, and sine squared is going to switch into 1 minus cosine squared. That way I'll be able to run my quad function, my quad program in the calculator. It's already set equal to 0 for me. Things are good to go. I'm going to distribute this 4 right here. So that would give me 4 minus 4 cosine squared minus 2 cosine plus 1. Clean that up. Now I make minus 4 cosine squared minus 2 cosine, and then 4 plus 1 is 5. Okay, now I can run it in quad. An a of -4, a b of -2, and a c of +5. And this time I get those decimal answers that aren't perfect, just like we did in section 1. So that means I'm going to have to do my arc cosine. Okay, so when I do my arc cosine, remember that I can't do things that are greater than 1 whole. So things that have an absolute value greater than 1 whole. So you'll notice in your calculator, the first answer is -1.39, and that one's automatically out because we know that cosine cannot equal something greater than 1. Immediately cross them out. Okay, so the only one I really care about is that decimal 0.89. Now remember, don't mess this problem up because of a rounding error. Go ahead and write down that whole decimal number. It takes 2 seconds, and that'll save you from messing up a problem because of a little bit of rounding. Okay, now this one's already positive. Remember that you always want to do an arc cosine of the positive value, no matter what this was. And we know that cosines are positive in quadrants, 1 and 4. Okay, and again, type in that whole decimal number, no rounding errors. 237. You could probably get away with a little bit of rounding, but why risk it, right? Okay, and when you type that in, find my work right here. There we go. That's going to give you the quadrant 1 answer of 26.4. Since quadrant 1 was one of the answers we wanted, sit right there. And then to switch to quadrant 4, remember we would subtract that from 360. To get our other answer of 333.6. There were no denominators in this one, so I don't have to be careful about dividing by 0. Those are my 2 answers. Done. Okay. Also notice that in pretty much all of these, they keep it in degree form, so you don't have to worry about switching your calculator back and forth, but do keep an eye on that right there in case they ever do try to switch things up on you and ask for a radian answer. Now this one right here, it looks like it's going to be nice and simple. Oh, I do have a cosine and a sine, and wait, right here, I have sine of 2 theta. So I've got to switch that out. So here's why I said you want to keep those chapter 7 notes handy. So hang on a sec, let me do sure. Here we go. So we learned these formulas right here. Okay, so sine of 2 theta, we had a couple of different options here. I could use this big mess, but it'd be much easier just to do this. So sine of 2 theta was also equivalent to 2 sine theta cosine theta. So that's the one I'm going to go with. Okay, so I'm going to swap out sine of 2 theta into 2 sine theta cosine theta. Okay, so this is 4 parentheses 2 sine theta cosine theta. Okay, so they are equivalent. One is the same as the other. Minus that 4 cosine theta equals 0. Okay, so this part right here turned into this part right here. All right, so I could clean that up just a little. 2 times 4 does make 8. And then, just like a problem we had in section 1, we said, okay, they're all mixed together here, but I could factor out the common cosine theta that they both have. Okay, so not only do they both have a cosine, but I could factor out the number 4. So 4 cosine theta could come out of both of those terms, leaving me with 2 sine theta from this first term. And this one, that's everything, so it would just be minus 1. Okay, just double check yourself in case your factoring is rusty. So right here, if I distributed this, 4 times 2 would be 8, sine cosine, yep. And then 4 cosine times 1 would be 4 cosine. So just double check that right there. Okay, and then remember that the reason we factor is so that we could set each of those factors equal to 0. 4 cosine of theta equals 0, or 2 sine theta minus 1 equals 0. And just that little bit of algebra, treat them just like 2 separate problems. This is a times, we undo a times by dividing. 0 divided by anything is still 0. Okay, this one I would add the 1, and of course divide by the 2. So that the sign would actually be that 1, and then divide by the 2, half. I'm going to skip a step right there. I believe in your algebra skills. All right, so cosine of 0 is going to be exactly in the middle, because remember cosine is like x, so that would happen at, if we're using degrees, 90 degrees, and straight down at 270 degrees. Okay, looking at our unit circle, sine is 1/2 in quadrants 1 and 2. So we find that there at 30 degrees and over there at 150 degrees. Okay. There are no denominators or no reason to kind of, break the mathematical rules. So those are our 4 answers. Now, for some reason, it asked you for all degree solutions. Remember, we just tack on a plus 2 pi k, but I don't think these did. So those would be our 4 answers. All right, we're almost there, guys. Now, one more little algebra refresher right here. It might not seem like we need it, but you'll see why once we start this problem. Now, remember, if I needed to solve something with the square root, we have to get that square root out of the way. We know we had some problems where we had to square root both sides and we had to tack on that plus or minus. So if I have a square root, I would square both sides. That kind of seems obvious. But what's not as obvious is when we square root it and put in that plus or minus, going the other way, we have something kind of sneaky happen. So keep an eye on it. So when I square the square root, it just cancels. It just leaves me with the 20 minus x. And then of course over here, x squared would be x squared. So here's a quadratic, so I can solve this. I can move either direction, whichever way you prefer. If you minus your x squared over here, kind of put things in nice, pretty order. Or you could add your x and your 20 over there. It all works out the same in the end. Then your calculator is going to give you 2 answers. So when I use my quad, I would get -1 for my A, -1 for my B, and a 20 for my C. I get the pretty answers of -5 and +4. But wait, here's that plus or minus I was talking about. You have to check your answers. When square roots are involved, you have to check. Watch this. If it were a -5, I should be able to plug in a -5 for my x and get a -5. Okay, so 20 minus x, -5, should equal x, -5. So replacing those x's with -5. So everything looks like it's going well. Minus to minus becomes a plus. 20 plus 5 is 25. And the square root of 25 is, wait a minute, positive 5, not negative 5. So there's where I kept saying that plus or minus. When we square root, we can put in the plus or minus, but when we square, we can't automatically eliminate the false solution. So it wasn't really plus or minus, it was really only plus. So because of that, we get this false solution. So we have to toss it. Now 4 is going to work out. So watch this one. 20 minus 4 is 16. And the square root of 16 is 4. So this one is good. And we had this one false solution because there wasn't really a plus or minus here. It was really only the plus. So that's why we got this accidental false solution. So anytime square roots are involved, you have to check those answers because they're sneaky false solutions. All right, so you say, why did we refresh on that? There's nothing going on square roots. But wait, sine of theta over 2. Look back over at my chapter 7 stuff. Here it is. Oh, there he is, square roots. So notice here's that plus or minus, that sneaky plus or minus. So I'm going to swap out sine of theta over 2 for this formula right here. Plus or minus 1 minus cosine theta over 2. Okay, I'm going to put the plus or minus there. Don't worry about it. It's all going to work out. It's not as sneaky as it looks. Over 2. Okay, so I just swap this out. This right here turned into this right here. Okay, and still have the minus cosine equals 0. Now I want to square root both sides, but if I want to square both sides, but if I squared it right now, I'd actually have to FOIL. So the first thing I'm going to do is move this cosine over there. So I actually have that the plus or minus square root of 1 minus cosine over 2 would be equal to cosine. Okay, because I add this cosine over because that makes life easier. Okay, now I can square both sides. So I'm going to go in and square both sides. Now again, there's not really a plus or minus. You say there is here, but there's not one here. So we have to watch the final answer for those false solutions. Okay, so when I square both sides, that's going to give me just regular 1 minus cosine theta over 2 equals, this one of course would now be cosine squared theta. Okay, so plus or minus goes away because plus times plus is positive, minus times minus is also positive. So when I squared it, this plus minus just kind of got absorbed. Okay, because a negative squared is still a positive. Okay, so right here, I want to solve this. I do have a denominator there. We don't like denominators, so let's multiply both sides by 2. Okay, so we're just multiplying by 2 over 1. That would give me 1 minus cosine equals, since I multiplied it by 2, that would give me 2 cosine squared. Okay, so all I did, I switched this out. I moved the cosine over. We squared both sides to get rid of that square root. And then to get rid of this denominator, I multiplied both sides by 2. So now it's much cleaner here. Okay, now I see that I'm on the right track. I've got the cosine squared, so I can use my quad program. Let's get it all on one side, just like we were doing over here. So that would give me negative 2 cosine squared minus cosine plus 1 equals 0. Okay, just subtracting this over here. So minus the 2 cosine over here. You could go either direction, it all works out. Now I'm going to use my quad program. So my A would be negative 2, my B would be negative 1, my C would be positive 1. I get that the cosine would then either be equal to negative 1 or cosine would be equal to positive 1/2. Okay, I'm running my quad. All right, almost there. So this one right here, cosine is equal to -1 in only one place. It's all the way over there to the left on the unit circle at 180 degrees. Cosine is equal to 1/2 in two places, in quadrants 1 and 4, where cosines are positive. That would be at 60 degrees and at 300 degrees. Okay, but we have to check these answers. So let's type these in. So we're going to type them into the original. Extend the page just so I can show you exactly what we're doing. So I would go sine. You don't have to write these all down, but you need to type them in your calculator. Of 180 over 2. So we're using the very original equation. Minus cosine of 180. Make sure it equals exactly 0. Okay, we're going to do that all 3 times. Then I would do sine of 60 over 2 minus cosine of 60. Make sure that also equals 0. And then one last time for the 300. So I would go sine of 300 over 2 minus cosine of 300. Okay, and make sure that that is also equal to 0. All right, so try all 3 of those. This one works fine. This one works fine, but this one actually, instead of a 0, gives you a 2. It's because sine of 180 over 2, sine of 90 is 1. Cosine of 180 is -1, like we just found right there. And 1 minus the -1 is equal to 2, which is not 0. So that means this guy's out. So our final answers are 60 and 300 only. So you have to check those answers. Anytime square roots are involved, answers must be checked. Okay, so it's the sneakiest one of the batch. But as long as you kind of follow those algebraic steps like you already know, okay, just got to kind of keep the trig from overwhelming you. It all works out. So the only time we really had to deal with trig was right here in the last step, and then it was just a matter of looking at the unit circle. So it's really just algebra in this section right here. So we have one more section like this with a little bit of algebra refresher, and then we have that chapter 10. Okay. All right, you got this.